In this video, we'll understand what a terminal is, we'll explore various commands, and we'll also talk about bash scripting. Now before I start, I want you to know about something called shell. Shell acts as the layer between the user and the operating system. It is a program that interprets user commands and executes them. Terminal, on the other hand, is an application that allows user to access the shell. Now the most basic thing you might want to do in your terminal is navigating and manipulating the file system, or in simple words, everything that you can do in your file manager. So let's open our file manager. The first thing you see when you open your file manager is a list of files and directory. You can achieve the same thing in your terminal by using the command ls. Every command has some flags, also known as options or switches, which allows us to customize the behavior of the commands and unlock additional functionalities. For example, if we use ls-a, it will list all the files and directories, including the hidden ones. ls-r recursively prints all the contents of directories and subdirectories. ls-t sorts the directories and files by modified time. We can also combine these flags. For example, ls list everything short by time and in a human readable size format. Okay, coming back to the file manager, you can check your current working directory in your terminal using the command pwd. To change directory, which simply means to open a folder, you can do that using cd. mkdir lets you create a directory. Touch lets you create a file. rm lets you remove a file. rm-rf will force remove a directory. Cat is used to view the contents of a file. Less is similar to cat but better. You can search in it. Head lets you see first few lines of a file. With flag -n, we can specify the number of lines. Tail lets you see the last few lines of a file. cp lets you copy a target file to a destination. mv lets you move a file. We can also use mv to rename a file. grep is used to pattern match. Shed lets you find and replace text. Sort sorts data alphabetically by default. Top lets you monitor your system. Now let me tell you something interesting. Whenever you type a command, say ls for instance, the shell searches for this command in specific directories like /user/bin or /user/local/bin, where the binary files or the executable files of these commands are located. You can know the location of any command using another command called which. It gives us the location of the executable file. Let's cd into /user/bin and check that out. As you can see here, there are a lot of binary files here. There's cat, ls, cp. You can put your own binaries into this and it will be available throughout the system as a command. Let's look at an example. I'll create a simple C file that prints hello world. We'll compile and create a binary called hello. Now let's give execution permissions and let's move the file to /user/bin. Now when I type hello, it says hello world. Even if I change the directory, it still works as it is available to us globally in the system like a command. We have talked about shell, right? So there are a lot of shell like Z shell, she shell, fish, but the default shell that comes with most Linux distribution is the bash shell. And bash scripting allows user to automate repetitive tasks by writing a sequence of command and logic in a script file. Let's look at an example. In our C programming lab, we use a text editor called gedit to create and edit C files. Then we compile it manually and run the executable. Even if I make a small change, I have to go through the whole process again and again. Let's automate this. I'll create a file called auto.sh. Now I'll list all the commands here. First, we edit the file with gedit and then a $1, which means the first argument passed to the script. Now compile and create a binary output and execute it. Let's give execution permission to auto and run auto.sh with an argument which is going to be the name of the C file. And here's the output. We just automated all of that. Let's run it again. I'll make some changes, save and quit. Here's the error. But it also runs the previous output file. As you can see here in the script file, it runs the .out file without checking if there is any error or not. So let's put a if condition. $? Will give us the exit code of the previous command. If it's equal to 0, then run the output and close the if. This is a little weird syntax of if in bash. Now if I run it, it does not run the output file when there is an error. And with that, we have automated the whole process in a single command. Make sure you hit that subscribe button, give this video a thumbs up, and that's it. Until next time.